Thank you all for being here. I'm going to talk about a benchmark I did in May last year on the context of a problem I was trying to solve for Liquid. So I'll go over how we ended up doing that context on a series of machine learning services, those by Amazon, Google, and Microsoft. And in the end, what we ended up doing to include machine learning in our product. And hopefully along the way, you can pick some tips on how to compare services and what aspects to consider when picking a machine learning solution for your business. Okay, so just a quick, am I doing this right? Okay, so Liquid is a mobile app analytics and engagement platform. We collect data from app usage and provide that data to our customers that are the app owners. And we were, at the time, trying to solve a very specific problem, which was that of churn prediction. So based on a user's recent activity in a certain mobile app, is the user going to return within 2 weeks' time? So we wanted to use machine learning to predict whether or not the user would return based on its recent activity. And at the time, Amazon had just released their machine learning service, and everybody was asking, how does this machine learning service compare to others, namely those by Google Predict and Microsoft Azure machine learning. So we set out to find out if any of these services outmatched the others, and also if any of these services was appropriate to solve the task at hand. I have written a blog post on this benchmark, so most of the details you can read it later. I'll give you the link to the blog post. I'll go over some of the major aspects and also why I think they should be considered when I have to do a comparison similar to this one. Okay, so just some general non-technical aspects regarding these services. I'd like to point out a couple of things. One is that none of these services allow you to inspect or export your model. And personally, I find it very useful to inspect models especially when things go wrong. It's sometimes a very useful diagnosis for what's taking place in the models you train. And in terms of prices, I did at the time a comparison and an estimate on the cost. And assuming that that Liquid only trained a single model and using the volume of data we had around May last year, Amazon would cost us about 60 euros per month. Google would cost us 200 euros per month, and Microsoft would cost us 600 euros per month. Okay, so that's the sort of range of data costs that we had, Azure being about 10 times more expensive than Amazon. Moving on to some more technical aspects. Today I'm going to talk about some data preprocessing, the choice of algorithms you have available, and also a quick overview in terms of the performance of these services on some of Liquid's data. In terms of data preprocessing, we have spoken about it today, but it's basically taking your raw data and structuring it and cleaning it so as to build good data from which your model can learn from. And this includes a series of operations such as data cleaning and dealing with missing values. Say in our case, for some users we didn't have the age, so we could either discard users for which we didn't know the age, we could try to replace the age with the average age, or try to estimate it from other traits of that user. So there are a series of techniques that you can use to enrich your data for training. And there's also this bit of a dark art called feature engineering, which is basically taking the data you have and build richer information from it to facilitate your model's task when learning. Okay? And this has been told time and time again today, but it really is a very important step that's sometimes overlooked when you're building a machine learning application. Okay? It really plays an important role in terms of what your model can extract from the data, the sort of operations that you do before actually feeding the data to the model. Okay? And considering that many technologies nowadays can perform operations, many operations on data quite efficiently, it's sometimes preferable to keep these operations on your side before actually sending the data to any machine learning service. Just a quick overview. You can later on check this in more detail. I'd just like to point out that Azure does have a lot of functionalities available for you. Amazon has the basic ones and a good set of tools available as well. And so does Google, though they do most things automatically, so be sure to check the documentation to make sure they're doing something that actually is useful in your case. On to the algorithms, and to keep this not too complex, there are two big families of algorithms for this sort of tasks where you're trying to either predict a label or a quantity. In our case, to predict churn, we were trying to predict a label. And there are two big families of models, okay? They're called linear and nonlinear, which is basically saying simple and not so simple. So linear models have, of course, they are they have much merit in terms of being the first approach to any machine learning problem. They are simple to understand, they are easy to set up and to tune on your data, so they are a very commendable first approach to any machine learning task that you have at hand. Of course, being simple, their expressive power is limited, and they may not mimic perfectly well the type of function you're trying to predict. So when that happens, you may have to switch to nonlinear models, which are slightly more complex. They are much more expressive, and they can mimic virtually any function you want from your data, but that comes with a price. And the price is they are prone to overfitting. Jose mentioned this before, but overfitting basically consists in your model memorizing your training data rather than actually extracting useful patterns from them. And in practical terms, when you take a model that has overfit and put it in production, things are gonna go really wrong real quick. Okay? Basically, you overestimate your model's performance. Out of these nonlinear models, there's one I'd like to point out, which is called the random forests. We've talked about them today. It's really almost a no-brainer solution because they are empirically super successful. They work on a series of data. They are robust to a lot of mishaps, such as missing data, outliers, noise, bad preprocessing, you name it. They are very robust models in that sense, but they can be misused and can overfit quite easily. And this, just a quick comparison, both Amazon and Google Predict use linear models, although Google doesn't mention it. There's a theory that they do use linear models, and Azure offers you a lot more models, including random forests. In terms of performance, I just did a very quick test using some data from one of our customers, and the performance, basically nobody stands out. I've added a fourth competitor, which is a linear model from a Python package called scikit-learn. Maybe some of you have used it before. It can help you set a baseline for comparison, but basically no one stood out in terms of performance. Okay, and that's it for the benchmark itself, the main results from the benchmark we ran. What did we do after that? So the conclusion we got to was for these services, none of them actually offered the flexibility and functionality that we wanted to have for the price. So we opted to build our own internal machine learning solution. Now, if you search for machine learning technologies for building custom solutions, you are bound to come across two technologies, Hadoop and Spark, and they've been mentioned today as well. And while they are tools with a lot of merit, and they are indeed very powerful, they are mostly directed to really large-scale distributed computing and processing of data. And although that is indeed very useful for large-scale companies with huge amounts of data, at the time, Liquid simply did not have that volume of data that required such complex tool. And from our point of view, it required a bit too much of an effort. Namely, it required too much time to set up, in particular for connecting these technologies with what we used at the time. And so we opted for a much simpler, almost a single machine solution using much simpler technologies. So Flor mentioned the Python clan before. We are part of the Python clan, and we opted to build an eternal web service built exclusively in Python for doing most of the machine learning calculations and data preprocessing. And this allowed us to keep our data where we usually stored it. It's always been in MongoDB, which for those of you who don't know, it's a non-relational database that deals with large-scale data extremely efficiently. And so we were able to keep the data in our original data source while using a simpler language that we were familiar with for doing the machine learning computing. And sure, this is not distributed. It's not that easy to build a parallel version of most of our functionalities, but it worked just fine for our scale. And it allowed us to build later on it if we need to, when we need to. So just a quick overview of how it goes. Okay. So the data enters here, and we store it immediately in our database. And we do two things in terms of machine learning. First, we periodically extract data from Mongo to send it to a separate web service built exclusively in Python for training. And also, as new data arrives, we send it immediately for prediction. So as a new user comes and makes a new session in an app, we immediately collect that data and send it to our trained models to assess, is this user going to return or not? And, a quick word about the packages we are using. Like I said, it's built mostly in Python. And Pandas is a very convenient package for doing data preprocessing. And it offers a series of data transformation tools. If you ever used R, you'll find it extremely easy to work with. Scikit-learn is the most famous machine learning package for Python. It's also intuitive to use. Theano is more deep learning oriented. And also, a quick word about the API, which was built using Flask. And it's also a Python package, but it's an extremely lightweight framework for building web services. If you ever heard of Django for Python or Rails for Ruby, it's exactly the same thing, but much, much simpler. It can be as simple or as complex as you want to. And in our case, using a few Python scripts, so just a couple of files, we were able to set up an interface for our internal web service within, say, 2 days. Okay, so that sums up our solution. And now, hopefully, the most interesting part for you guys, which is what can you do? Okay, so when time comes for you to choose a machine learning service, what aspects should you consider? And of course, there's no generic answer for everybody. So I think there are a couple of things to point out. So if you decide to use an external provider, do keep in mind that you don't need to be a data science to understand and to use these services, though I do advise you to have some machine learning knowledge. In particular, it can help you correctly assess the models, because as we can see, it can go extremely wrong if done wrongly. It also allows you to understand what's actually happening in the services you are using, okay? Understanding the tools you are using is, of course, much beneficial to you to better take value from them. And if on the other hand, you decide to adopt Liquid's position and build your own solution, of course, you'll need more machine learning knowledge and more technical knowledge to actually get a solution up and running. But that doesn't mean you have to go for over-the-top edge solutions, you can use much simpler technologies that allow you to get solution in production up and running much faster with much less fuss, provided you can build on it later on as your business grows. In terms of alternatives, we've seen a lot of alternative services today in this conference. I'd like to point out a few more. BigML is a generic machine learning service that uses random forest. Prediction.io is an open source machine learning server. They contain a series of templates in Scala that you can either use off the shelf using API calls, or you can export them and customize them to your needs. It's slightly a different approach. And finally, Algorithmia is an algorithm marketplace that is credit-based, so you have to earn credits or buy credits to use the algorithms. But they contain a series of algorithms, and also not just for machine learning, so for other types of functionalities and tools and contexts, they also provide algorithms for it, so it's worth checking out. As for reading material, the first link is, like I said, the original blog post. If you want to see a more thorough comparison between the services, I strongly advise you to go there. It's much easier to follow in written format, I believe. Louis also did a benchmark that I think complements this one rather well. He focuses on other aspects, namely on speed and a bit more on the accuracy of the models. It's also worth checking out. And the last two links are some interesting readings if you ever think of benchmarking services for your own applications as well. First one has some tips on benchmarking in general, and the second one is a rather interesting discussion on machine learning services as well. And that's it. Thank you.